Hello there, and welcome to Tedious Science, where the biggest questions in the universe get explored with a gentle voice and a cup of something warm. I'm so glad you're here. Whether you're curled up in bed, winding down after a long day, or simply seeking a peaceful moment to ponder the mysteries of existence, you've found the perfect place. Tonight, we're embarking on a journey that has captivated human minds for thousands of years. A question so profound and beautiful that it has inspired philosophers, burned heretics, and driven scientists to the very edges of mathematical madness. Does space end or go on forever? It's a question that sounds deceptively simple, doesn't it? Like asking whether the ocean has a shore or if tomorrow will come. To say, but when you really sit with it, when you let it settle into your thoughts like tea steeping in hot water, you begin to realize just how wonderfully complex and mysterious it truly is. Before we drift into this cosmic exploration, I'd love to know where in the world you're listening from tonight. What do you see when you look up at the sky above you? Are you beneath a blanket of stars in the countryside? Or perhaps city lights are painting your night in warm, amber hues? Wherever you are, you're gazing up at the same infinite question that has puzzled humanity since we first learned to wonder. If you find this gentle voyage through space and time soothing, or if it sparks that quiet kind of curiosity that makes you want to learn more, I'd be ever so grateful if you gave this video a like and perhaps subscribe to join our little community of sleepy scientists. It helps others discover these peaceful explorations and lets me know that you'd like more of these cosmic bedtime stories. Now, I do hope this isn't so fascinating that it keeps you awake, but if it does, well, at least you'll drift off knowing a bit more about the universe that cradles us all. So settle in, close your eyes if you like, and let's begin our journey to the very edges of everything. Because somewhere in the vast expanse above us lies one of the most beautiful mysteries science has ever encountered. Imagine for a moment that you're standing in the middle of a vast field on a clear night. No city lights, no distractions, just you and the endless canopy of stars stretching in every direction above you. As you turn slowly in a circle, taking in the immensity of it all, a question begins to form in your mind, like a whisper from the cosmos itself. If I could somehow travel past all those stars, past all the galaxies and nebulae and cosmic dust, would I eventually reach a place where space simply ends? Would there be a wall, a boundary, a cosmic edge with a sign that reads, "Universe ends here. Thank you for visiting"? Or would I find myself travelling forever through an endless expanse of space and time, always discovering new regions, new galaxies, new mysteries, without ever reaching a final destination? It's the kind of question that makes you feel both incredibly small and wonderfully connected to something infinite, all at once. This question has haunted humanity for millennia, long before we had telescopes or spacecraft, or even a proper understanding of what stars actually are. Ancient civilizations looked up at the night sky and wondered about the nature of the cosmos. They saw the same stars we see tonight, though their eyes were unclouded by light pollution and their minds unencumbered by the complex mathematics of modern physics. The ancient Greeks, with their love of logic and philosophical debate, tackled this question with characteristic intensity. Aristotle, the great philosopher whose ideas would dominate Western thought for over 1,000 years, believed that the universe had to be finite. He reasoned that if stars extended to infinity, they could not complete their nightly rotation around Earth in just 24 hours. It seemed logical enough at the time, though we now know that Earth is the one doing the rotating, not the stars. But even then, there were those who dared to imagine something grander, something more infinite. Giordano Bruno, an Italian philosopher and mathematician, asked what seemed like an obvious question. If there is a boundary or edge to space, what lies on the other side? It's a question that still gives physicists delicious headaches today. Bruno's reward for such bold thinking was, unfortunately, rather grim. He was burned at the stake in 1600 for his advocacy of an infinity of suns and earths. A reminder that sometimes the universe's biggest questions come with the highest stakes. Then came Johannes Kepler, the brilliant German astronomer who, in 1610, provided what seemed like a compelling reason to believe the universe must be finite. He pondered that if there were an infinity of stars scattered throughout space, then the night sky would be completely filled with starlight, and night would not be dark. This became known as Olbers' paradox, after the astronomer who later popularized it. Why is the night sky dark if there are infinite stars to light it up? It's a beautiful puzzle, isn't it? And one that hints at the deep connections between the finite and infinite, the observable and the hidden, the known and the unknowable. These early thinkers were grappling with ideas that would later become central to our modern understanding of cosmology, though they lacked the mathematical tools and observational instruments we have today. As we journey deeper into this question tonight, we'll discover that the answer isn't as straightforward as those ancient philosophers might have hoped. Modern science has revealed that the universe is far stranger and more wonderful than anyone could have imagined, with possibilities that stretch the very fabric of reality itself. But let's start with something we can actually observe. Because while the question of infinite space might seem abstract and philosophical, it's actually rooted in very real measurements and observations that scientists have been making for decades. The key to understanding whether space goes on forever lies in a crucial distinction that many people don't realize exists: the difference between the universe and the observable universe. Think of it this way. Imagine you're standing on a beach at dawn. The sun is just beginning to rise and you can see the ocean stretching out to the horizon in every direction. That horizon represents the limit of what you can observe from your position on the beach, but just because you can't see beyond it doesn't mean the ocean ends there. The ocean might continue for thousands of miles beyond your visual range, or it might be infinite. You simply can't know from your current vantage point. The observable universe works in much the same way, except instead of being limited by the curvature of the Earth, we're limited by something far more fundamental: the speed of light and the age of the universe itself. Light travels at a finite speed, about 300,000 kilometers per second, which sounds incredibly fast until you consider the vast distances involved in cosmic scales. Since the universe is approximately 13.8 billion years old, light from the most distant objects has had 13.8 billion years to travel toward us. This creates a sphere around us with a radius of about 13.8 billion light years, beyond which we cannot see. Not because nothing exists there, but because the light from those regions hasn't had time to reach us yet. But here's where it gets beautifully complicated. The universe has been expanding ever since the Big Bang, so objects that emitted light 13.8 billion years ago are now much farther away than they were when that light began its journey toward us. When astronomers calculate the current distance to these objects, they find that they're now about 46.5 billion light-years away, making the observable universe a sphere with a radius of 46.5 billion light-years. This expansion means that every day, every moment, the observable universe grows a little bit larger as light from previously unreachable regions finally arrives at our telescopes. It's like standing on that beach and watching the fog slowly lift, revealing more and more of the ocean that was always there but hidden from view. The observable universe contains everything we can potentially study, measure, and understand directly. It's filled with hundreds of billions of galaxies, each containing hundreds of billions of stars, along with vast clouds of gas and dust, dark matter, and dark energy, all woven together in a cosmic web of breathtaking complexity. But as vast as this observable realm is, it may represent only a tiny fraction of what actually exists. Imagine that the observable universe is like a single grain of sand on an infinite beach. Each grain represents a region of space about 93 billion light-years across. filled with galaxies, stars, and all the matter and energy we can observe. Now imagine that beach stretching on forever, with countless grains of sand, each representing another region of space that we can never hope to see or study directly. This is one of the most humbling realizations in all of science, that despite our sophisticated instruments and elegant theories, we may be confined to studying just one tiny corner of a vastly larger, or perhaps infinite, reality. It's a bit like being a microbe in a drop of water trying to understand the nature of the ocean. But don't let this limitation discourage you, because what we can observe within our cosmic neighborhood is already so rich and strange that it will keep scientists busy for centuries to come. And remarkably, even from our limited vantage point, we can still make educated guesses about the nature of the larger universe by studying the geometry of space itself. You see, the universe isn't just a collection of objects floating in empty space. Space itself has properties, structure, and geometry that we can measure. And these measurements provide crucial clues about whether space extends infinitely or curves back on itself in some finite but unbounded way. The cosmic microwave background radiation provides our best window into the universe's overall geometry. This ancient light, the oldest we can observe, was emitted about 380,000 years after the Big Bang, when the universe first became transparent to light. Before this moment, the universe was so hot and dense that photons couldn't travel far without being absorbed or scattered by free electrons. It was like trying to see through a thick fog. But as the universe expanded and cooled, electrons combined with protons to form neutral hydrogen atoms. Suddenly the fog cleared, and light could travel freely through space for the first time. This moment, called recombination, released a flood of radiation that has been traveling through space ever since, stretched and cooled by the universe's expansion into the microwave portion of the electromagnetic spectrum. When we map this cosmic microwave background, we're essentially looking at a baby picture of the universe, seeing it as it was when it was just a fraction of its current age. The tiny temperature fluctuations in this radiation tell us about the density variations that would later grow into galaxies and galaxy clusters. But they also reveal something even more fundamental about the geometry of space itself. By carefully measuring the angular sizes of these temperature fluctuations, scientists can determine whether space is curved like the surface of a sphere, flat like a sheet of paper, or saddle-shaped like a horse's back. The results are quite remarkable. The universe appears to be geometrically flat to within less than 1% uncertainty. This flatness has profound implications for the question of infinity, because the geometry of space is intimately connected to its ultimate fate and extent. If the universe were positively curved like a sphere, it would be finite in size with a definite volume, though it would have no edges or boundaries, just as the surface of a sphere has a finite area but no edge. If the universe were negatively curved like a saddle, it would be infinite in extent, stretching on forever in all directions, but with a geometry that becomes increasingly distorted at large scales. But a flat universe, the kind we appear to live in, presents the most intriguing possibility of all. In principle, a flat universe could be either finite or infinite, depending on its overall topology or global structure. It's a bit like the difference between a flat sheet of paper that extends infinitely in all directions and a flat sheet that's been rolled into a cylinder or twisted into a Mobius strip. The simplest flat universe is indeed infinite, extending uniformly in all directions without any boundaries or edges. Such a universe would contain an infinite number of galaxies, stars, and potentially even copies of ourselves, existing in regions far beyond our observable horizon. It's a mind-bending possibility that would mean every possible arrangement of matter and energy exists somewhere in the vast expanse of space. But there's another possibility that's equally fascinating, a universe that's flat but finite, like a cosmic donut or torus. In such a universe, if you travelled far enough in any direction, you would eventually return to your starting point, having circumnavigated the entire cosmos. It would be like living on the surface of a donut, where you could walk in any direction and eventually come back to where you started. This possibility might sound far-fetched, but it's actually quite plausible from a mathematical perspective. There are many ways to create a flat, finite universe by connecting the edges of space in different patterns, like wrapping a flat sheet into a cylinder or connecting opposite edges to form a torus. These are called multiply-connected topologies, and they represent some of the most elegant solutions to the puzzle of cosmic geometry. If we live in such a universe, we might be able to detect it by looking for repeating patterns in the cosmic microwave background, or by spotting the same galaxy appearing in multiple locations in the sky, like seeing your reflection in a hall of mirrors. Each reflection would show the galaxy at a different age and distance as light took different paths through the wrapped geometry of space. Scientists have been searching for these telltale signatures for decades, using increasingly sophisticated techniques to map the cosmic microwave background and catalogue distant galaxies. So far, no conclusive evidence has been found for a multiply-connected universe. But the absence of evidence isn't necessarily evidence of absence. The universe might simply be so large that even if it's finite, the repeating pattern lies beyond our observable horizon. The search continues, though, because discovering that we live in a finite universe would be one of the most profound revelations in the history of science. It would mean that space, while unimaginably vast, is not infinite, and that somewhere out there, beyond the furthest galaxies, space curves back on itself in a cosmic loop. But let's consider the alternative possibility, that space truly is infinite, stretching on forever in all directions. This isn't just a larger version of what we can observe, it's qualitatively different in ways that challenge our deepest intuitions about reality and existence. In an infinite universe, every possible arrangement of matter and energy doesn't just exist, it exists infinitely many times. This is a consequence of basic probability and the finite number of ways that particles can be arranged within any given volume of space. If you have infinite space and a finite number of possible configurations, then every configuration must repeat infinitely often. This leads to what physicists call the infinite monkey theorem, applied to cosmology. Just as an infinite number of monkeys typing randomly would eventually produce every possible book, an infinite universe filled with randomly distributed matter would eventually produce every possible world, every possible version of Earth, every possible version of you. Somewhere in the infinite expanse, there's a planet exactly like Earth, where you made slightly different choices this morning. There's another where dinosaurs never went extinct, and another where the laws of physics are subtly different, allowing for entirely alien forms of life. The possibilities are not just endless, they're actually infinite. It's a concept that can make your head spin in the most delightful way, because it suggests that everything that can happen does happen. Somewhere in the vast cosmic library of infinite space, your dreams, your fears, your wildest imaginings all exist as physical realities in some distant corner of the universe. But infinity brings its own peculiar problems that would make even the most patient mathematician reach for a very strong cup of tea. How do you compare infinite quantities? How do you say that one infinite set is larger than another? These aren't just abstract mathematical puzzles. They're real issues that cosmologists grapple with when trying to understand an infinite universe. For instance, in an infinite universe containing every possible arrangement of matter, you would expect to find regions that are exact copies of our observable universe, down to the last atom. But you'd also find regions that are almost identical, but with tiny differences, like a single photon pointing in a slightly different direction. The question then becomes, which of these infinite copies is the real you, or are they all equally real? This touches on deep philosophical questions about identity, consciousness, and the nature of existence itself, questions that keep philosophers awake at night, pondering the implications of infinity. The expansion of the universe adds another layer of mystery to our cosmic puzzle. When Edwin Hubble first discovered that distant galaxies are moving away from us with speeds proportional to their distance, he revealed that space itself is expanding. The universe is getting bigger. But this doesn't necessarily mean it's growing into something larger. If the universe is infinite, then it was infinite at the moment of the Big Bang, and it remains infinite now. When cosmologists say the universe is expanding, they mean that the distance between galaxies is increasing over time, not that the universe has a certain size that's growing. The infinite universe simply becomes less dense as it expands, with galaxies moving further apart, but the total extent remaining infinite. This expansion creates a dynamic situation where new regions of space are constantly coming into view as light from ever more distant galaxies reaches us. But simultaneously, some regions are receding from us so quickly due to the expansion that their light will never reach us, no matter how long we wait. The discovery that the universe's expansion is accelerating, driven by the mysterious dark energy, makes this picture even more complex. Dark energy appears to be a property of space itself, causing empty space to expand at an ever-increasing rate. This acceleration means that galaxies beyond a certain distance are moving away from us faster than light can travel, creating a cosmic event horizon beyond which we can never see. It's a bit like trying to swim upstream in a river that's flowing faster than you can swim. No matter how hard you try, you'll never reach your destination because the current is carrying you backward faster than you can move forward. In the same way, light from the most distant galaxies is fighting against the expansion of space itself. This accelerating expansion has profound implications for the future of our observable universe. Over billions of years, galaxies outside our local group will disappear from view. One by one, their light stretched to such long wavelengths that it becomes undetectable. Future astronomers living in this far distant epoch will see a much lonelier universe, with only the galaxies in our immediate neighborhood visible in the sky. But what about the universe beyond our observable horizon? If space is infinite, then this acceleration doesn't change that fact. It simply affects what we can see and study directly. The infinite universe continues to exist beyond our cosmic event horizon, forever hidden from our view, but no less real for being unobservable. The concept of dark energy also raises intriguing questions about the ultimate fate of space itself. Recent observations suggest that dark energy might not be constant, but could be changing over time, weakening in a way that might eventually allow matter to dominate once again. If dark energy continues to weaken over cosmic timescales, the universe might eventually stop expanding and begin to contract, leading to a big crunch where all of space collapses back into a singularity. Alternatively, dark energy might strengthen over time, leading to a scenario called the Big Rip, where the expansion of space accelerates so dramatically that it tears apart galaxies, solar systems, and eventually even atoms themselves. In this scenario, the infinite universe wouldn't end, but it would become a cold, empty expanse devoid of any structure or complexity. These possibilities remind us that even if space is infinite, it's not static. The universe is dynamic, evolving, changing in ways that affect both the observable and unobservable regions. The question of whether space ends or goes on forever is intimately connected to questions about time, the beginning and end of everything, and the ultimate fate of all existence. But perhaps the most mind-bending possibility of all comes from the theory of eternal inflation, which suggests that our observable universe might be just one bubble in an infinite sea of space that's constantly creating new universes through a process that never ends. According to this theory, the rapid expansion that occurred in the first fraction of a second after the Big Bang, called inflation, didn't happen just once in our region of space. It's happening constantly throughout an infinite multiverse, creating new bubble universes like soap bubbles, forming in an infinite bath. Each bubble universe, like our own, would have its own Big Bang, its own expansion, its own galaxies and stars. But the space between the bubbles would continue to inflate forever, creating room for infinitely many more universes to form. This eternal inflation would make the question of whether space is infinite almost trivial, because space wouldn't just be infinite, it would contain an infinite number of separate universes, each with potentially different laws of physics and fundamental constants. The eternal inflation theory emerged from attempts to solve certain puzzles in cosmology, such as why our universe appears so uniform and flat on large scales. But it leads to consequences that are even more extraordinary than the problems it was designed to solve. If eternal inflation is correct, then not only is space infinite, but it contains infinite copies of our universe, infinite copies of ourselves, and infinite variations on every possible theme. In this infinite multiverse, every story that could be told is being told somewhere. Every dream that could be dreamed is being lived. Every possibility that could exist does exist. It's a vision of reality so vast and rich that it challenges our ability to comprehend it. Yet it emerges naturally from our best theories about the early universe and the nature of space and time. The implications of such a multiverse are both beautiful and bewildering. If eternal inflation is correct, then somewhere in the vast expanse of inflating space, there's a universe where you decided to become an astronaut instead of whatever path you've chosen. There's another where the dinosaurs developed space travel, and yet another where the fundamental forces of nature are just different enough to create entirely alien forms of chemistry and life. But this raises what physicists call the measure problem, and it's one of those delightfully frustrating puzzles that keeps theorists awake at night. In an infinite multiverse where every possible event occurs infinitely many times, how do you calculate the probability of anything? It's like asking whether there are more odd numbers or even numbers in the infinite sequence of integers. Both sets are infinite, so the usual rules of probability simply break down. This isn't just a mathematical curiosity, it's a fundamental challenge to making predictions about reality. If every possible universe exists somewhere, then any observation we make could be explained by saying, well, we just happen to live in the universe where that's true. It's a bit like trying to understand the nature of libraries by examining just one book, except in this case, the library is infinite and contains every book that could ever be written. Stephen Hawking, in his final work before his death, attempted to address some of these puzzles. He proposed that the multiverse might be finite after all, with only a limited number of possible universes emerging from eternal inflation. This would make the theory more testable and predictive, though it would still leave us with the question of whether our particular bubble universe is finite or infinite. The search for answers to these cosmic riddles continues in laboratories and observatories around the world. Scientists are mapping the cosmic microwave background with ever greater precision, looking for subtle patterns that might reveal the topology of space. They're measuring the expansion rate of the universe, studying supernova and gravitational waves, all in hopes of understanding the ultimate nature of the cosmos. But there's something wonderfully humbling about this quest. Despite all our sophisticated instruments and elegant theories, we're still like children standing on the shore of an infinite ocean, picking up the occasional pretty shell and thinking we understand the sea. The universe keeps its deepest secrets just beyond our reach, always offering new mysteries to contemplate. Consider for a moment the sheer audacity of the question we're asking. Here we are, tiny beings made of star stuff, living on a small planet orbiting an ordinary star in an unremarkable galaxy, and we're wondering about the ultimate extent of everything that exists. It's simultaneously the most natural question in the world and the most presumptuous. Yet somehow, through careful observation and mathematical reasoning, we've managed to constrain the possibilities and make educated guesses about the nature of infinity itself. The cosmic microwave background has been particularly generous in revealing its secrets. When scientists first detected this ancient radiation in the 1960s, it appeared perfectly uniform in all directions. But as instruments became more sensitive, tiny fluctuations emerged, variations in temperature of just a few millionths of a degree. These whispers from the early universe tell us about the seeds that would grow into galaxies and reveal the geometry of space itself. The patterns in this radiation are like cosmic fingerprints, encoding information about the fundamental parameters of the universe. By measuring the angular size of these fluctuations, scientists can determine whether space is curved or flat with remarkable precision. The result, as we've seen, is a universe that appears to be geometrically flat to within a fraction of a percent. This flatness is both a blessing and a curse for those trying to understand cosmic infinity. It rules out certain models of a finite universe, like a spherical cosmos that curves back on itself. But it leaves open both the possibility of true infinity and the more exotic option of a flat universe that's finite but unbounded, like a cosmic donut or pretzel. Or the search for cosmic topology has become increasingly sophisticated over the decades. Scientists have developed ingenious methods to look for the signatures of a finite universe, such as correlated patterns in the cosmic microwave background that would indicate we're seeing the same region of space from different directions. They've searched for duplicate images of galaxies, hoping to spot the same object appearing at different distances and ages as light takes different paths through a wrapped universe. So far, these searches have come up empty, but that doesn't necessarily mean the universe is infinite. It could simply mean that if the universe is finite, it's so large that the repeating pattern lies beyond our observable horizon. It's like trying to determine whether you're standing on a sphere by examining only a small patch of ground beneath your feet. If the sphere is large enough, that patch will appear perfectly flat, giving no hint of the underlying curvature. The expansion of the universe adds another layer of complexity to our cosmic detective story. When Edwin Hubble first discovered that distant galaxies are receding from us, he revealed that space itself is growing larger. But this expansion doesn't necessarily tell us whether space is finite or infinite. An infinite universe that was infinite at the Big Bang remains infinite as it expands, while a finite universe simply becomes less dense as it grows. The discovery that this expansion is accelerating, driven by the mysterious dark energy, has profound implications for what we can observe. Dark energy appears to be a property of empty space itself, causing regions of space to expand at an ever-increasing rate. This acceleration creates a cosmic event horizon, beyond which galaxies recede from us faster than light can travel, forever hidden from our view. Recent observations suggest that dark energy might not be constant but could be evolving over time. Some measurements hint that it might be weakening, which could dramatically alter the universe's future evolution. If dark energy continues to weaken, the expansion might eventually slow down, stop, and reverse, leading to a big crunch where all of space collapses back into a singularity. Alternatively, dark energy might strengthen over time, leading to an even more dramatic scenario called the Big Rip. In this case, the expansion would accelerate so violently that it would tear apart galaxies, solar systems, and eventually even atoms themselves. The universe wouldn't end in this scenario, but it would become a cold, empty expanse devoid of any structure or complexity. These possibilities remind us that the question of spatial infinity is intimately connected to questions about time and the ultimate fate of everything. Even if space goes on forever, it's not a static infinity, but a dynamic, evolving one that changes in ways we're only beginning to understand. But perhaps the most fascinating aspect of this cosmic puzzle is how it connects to our everyday experience of existence. The question of whether space is infinite isn't just an abstract mathematical problem. It's a question about the nature of reality itself. If space goes on forever, then every possible arrangement of matter and energy exists somewhere in the vast expanse. Every story that could be told is being lived. Every dream that could be dreamed is someone's reality. This has profound implications for how we think about uniqueness, meaning, and our place in the cosmos. If there are infinite copies of ourselves scattered throughout infinite space, making slightly different choices and living slightly different lives, what does that mean for personal identity? Are we unique, or are we just one of infinitely many variations on a theme? These questions touch on some of the deepest philosophical issues humans have ever contemplated. They challenge our intuitions about existence, consciousness, and the nature of reality itself. Yet, they emerge naturally from our best scientific theories about the universe, reminding us that science and philosophy are never far apart when we're exploring the ultimate questions. The mathematical frameworks we use to explore these possibilities are themselves things of beauty. The equations of general relativity, with their elegant description of curved spacetime, provide the language for discussing cosmic geometry. The principles of quantum mechanics, with their emphasis on probability and uncertainty, offer insights into the nature of reality at the smallest scales. And the theories of inflation and eternal inflation, with their predictions of multiple universes and infinite possibilities, push the boundaries of what we can conceive and test. Yet for all their mathematical sophistication, these theories still leave us with fundamental mysteries. We don't know whether the universe is finite or infinite. We don't know whether we live in a multiverse or a single cosmos. We don't know whether space has an edge or extends forever in all directions. These are questions that may ultimately be unanswerable, not because of limitations in our instruments or theories, but because of the fundamental nature of infinity itself. Perhaps that's fitting. Perhaps some questions are meant to remain mysteries, not to frustrate us, but to inspire us. The question of whether space ends or goes on forever has driven centuries of scientific progress and philosophical reflection. It has led us to discover the expansion of the universe, the cosmic microwave background, and the bizarre properties of dark energy. It has forced us to confront the limits of human knowledge and the nature of existence itself. And in a sense, the question is as beautiful as any answer we might find. Standing beneath the star-filled sky, contemplating the possibility that space extends forever in all directions, we're participating in one of humanity's greatest adventures. We're using the spark of consciousness that emerged from billions of years of cosmic evolution to contemplate the very cosmos that gave us birth. Whether space is finite or infinite, whether we live in one universe or infinitely many, we find ourselves here, now, in this moment of cosmic history, able to wonder about the ultimate nature of everything. In a universe that might contain infinite copies of ourselves, this particular version of you is here, listening to these words, pondering these possibilities. And that, perhaps, is the most beautiful mystery of all. So, here we are, gently floating through the cosmos of possibilities, like dandelion seeds on a cosmic breeze. And we find ourselves approaching perhaps the most mind-bending territory of all, a realm where the very concept of infinity becomes not just a mathematical abstraction, but a lived reality, with implications so profound they make even the most seasoned physicists pause and reach for another cup of tea. Let me paint you a picture of what an infinite universe might actually contain, and I promise this will be far stranger than any dream you've ever had. Imagine, if you will, that space truly does extend forever in all directions, stretching on without end through dimensions we can barely fathom. Now, within any finite region of space, there are only so many ways that atoms and molecules can arrange themselves. It's an enormous number, certainly, but still finite, like the number of possible arrangements of letters in a library, or the number of ways you can shuffle a deck of cards. Now, here's where it gets deliciously peculiar. If space is infinite and matter is distributed throughout it, even roughly uniformly, then every possible arrangement must occur not just once but infinitely many times. It's a consequence of basic probability theory applied to infinite space, and the implications are enough to make your head spin in the most wonderful way. This means that somewhere in the vast expanse of space, there exists a planet exactly like Earth, where you made slightly different choices this morning. Perhaps you chose tea instead of coffee, or decided to wear a different colour shirt. There's another Earth where you became an astronaut instead of whatever path brought you here tonight, and another where you speak an entirely different language, but still find yourself wondering about the nature of infinity. The mathematician and cosmologist Max Tegmark has calculated that your nearest identical copy, assuming the universe is infinite and uniformly filled with matter, would be located approximately 10 to the power of 10 to the power of 29 meters away. That's a number so large it defies comprehension, a 1 followed by more zeros than there are atoms in the observable universe. But in an infinite cosmos, such distances become almost quaint. There would be entire regions of space containing exact duplicates of our observable universe, down to the last photon and gravitational wave. But there would also be near duplicates with tiny variations, perhaps a single electron spinning in the opposite direction, or a distant star flickering just a moment sooner. These variations would cascade through time, creating universes that start identically but diverge in subtle ways, like parallel stories being written simultaneously across the infinite expanse. But the infinite universe doesn't stop at mere duplicates. It contains every possible variation, every story that could be told, every arrangement of matter and energy that the laws of physics permit. Somewhere, there's a version of Earth where dinosaurs never went extinct and developed their own sophisticated civilization, complete with philosophy, art, and perhaps even their own theories about cosmic infinity. There's a region where the fundamental constants of nature are slightly different, allowing for entirely alien forms of chemistry and life forms so strange they would seem like magic to us. There are worlds where gravity is a bit weaker, where light travels at a different speed, where the electron has a slightly different charge, each variation creating its own unique flavour of reality. This isn't science fiction. It's a direct consequence of the mathematics of infinity combined with our best understanding of how matter behaves in the cosmos. If the universe is truly infinite, then these possibilities aren't just theoretical. They're as real as the device you're listening to this on right now, existing somewhere in the vast library of infinite space. The concept becomes even more extraordinary when you consider that consciousness itself would be scattered throughout this infinite expanse. Every possible mind that could exist does exist somewhere, thinking its own thoughts, dreaming its own dreams, contemplating its own version of the infinite cosmos. There are versions of you having this exact thought right now, but in slightly different circumstances, perhaps under different stars or in a room with different coloured walls. It's a vision of reality so rich and vast that it challenges our deepest assumptions about uniqueness, identity, and meaning. In an infinite universe, nothing is truly unique because everything occurs infinitely many times. Yet paradoxically, this makes each moment, each choice, each experience infinitely precious because it's part of an infinite symphony of existence. But infinity brings its own peculiar challenges that would make even the most patient mathematician want to take a very long nap. How do you navigate a reality where every possible outcome occurs infinitely many times? How do you make sense of probability when every event, no matter how unlikely, happens constantly across the infinite expanse? This leads to what philosophers call the problem of infinite ethics. If every possible action occurs infinitely many times across infinite space, then what meaning can we assign to moral choices? There are infinite versions of you making every conceivable decision, from the most virtuous to the most questionable. Does this render individual responsibility meaningless? Or does it make each choice more significant because it's part of an infinite moral landscape? These aren't just abstract philosophical puzzles. They're real questions that emerge naturally from taking the possibility of cosmic infinity seriously. And they remind us that the question of whether space goes on forever isn't just about physics and mathematics. It's about the very nature of existence, meaning, and what it means to be human in a possibly infinite cosmos. But let's drift back toward the more measurable aspects of our cosmic journey, because while the implications of infinity are mind-boggling, the search for answers continues in laboratories and observatories around the world. Scientists are developing increasingly sophisticated methods to probe the nature of space itself, using instruments that can detect the faintest whispers from the early universe. One of the most promising approaches involves studying the polarization of the cosmic microwave background radiation. Just as sunlight becomes polarized when it reflects off water, the ancient light from the early universe carries subtle polarization patterns that encode information about the geometry and topology of space. By mapping these patterns with exquisite precision, scientists hope to detect signatures of cosmic curvature or topology that might reveal whether space is finite or infinite. Another approach involves looking for gravitational wave signatures from the early universe. These ripples in space-time itself carry information about the fundamental structure of the cosmos and might reveal evidence of cosmic boundaries or the infinite nature of space. Advanced detectors like LIGO and Virgo are already detecting gravitational waves from colliding black holes and neutron stars. But future instruments might be sensitive enough to detect the primordial gravitational waves that would carry information about the very fabric of space. The study of dark matter and dark energy also provides clues about cosmic infinity. These mysterious components make up about 95% of the universe, yet we know remarkably little about their true nature. Dark matter seems to provide the gravitational scaffolding that holds galaxies together, while dark energy drives the accelerating expansion of space. Understanding these phenomena better might reveal whether they're consistent with an infinite universe, or whether they point towards some kind of cosmic boundary or edge. Recent observations have suggested that dark energy might be evolving over time, becoming stronger or weaker in ways that could dramatically affect the universe's future evolution. If dark energy continues to strengthen, it could lead to a scenario where the expansion of space accelerates so dramatically that it tears apart the very fabric of space-time itself, creating what cosmologists call a big rip. In such a scenario, the question of whether space is infinite becomes moot because space itself would be destroyed. But if dark energy weakens over time, the expansion might slow down, stop, and reverse, leading to a big crunch where all of space collapses back into a singularity. These possibilities remind us that even if space is infinite, it's not static but dynamic, evolving in ways that could fundamentally alter its nature. The search for cosmic topology has also become increasingly sophisticated over the decades. Scientists have developed ingenious methods to look for the signatures of a finite universe, such as correlated patterns in the cosmic microwave background that would indicate we're seeing the same region of space from different directions. It's like looking for echoes in a vast cosmic cathedral where the same sound reaches you from multiple directions, having bounced off the curved walls. They've also searched for what are called cosmic crystallography patterns, looking for regular structures in the distribution of galaxies that might indicate we're seeing the same cosmic structures repeated due to the topology of space. It's a bit like looking at a wallpaper pattern and trying to determine whether it repeats or extends infinitely in all directions. So far, these searches have come up empty, but that doesn't necessarily mean the universe is infinite. It could simply mean that if the universe is finite, it's so large that the repeating pattern lies beyond our observable horizon. It's like trying to determine whether you're standing on a sphere by examining only a small patch of ground beneath your feet. If the sphere is large enough, that patch will appear perfectly flat, giving no hint of the underlying curvature. The development of quantum gravity theories has also opened new avenues for understanding cosmic infinity. These theories attempt to merge quantum mechanics with general relativity, creating a framework that might describe the very fabric of space-time at the smallest scales. Some approaches, like loop quantum gravity, suggest that space itself might be quantized. made up of discrete units rather than being continuous. This could have profound implications for the question of infinity. If space is indeed quantized, then there might be a smallest possible unit of space, just as there's a smallest unit of electric charge or angular momentum. This could mean that while space appears continuous at large scales, it's actually made up of tiny discrete building blocks, like pixels on a cosmic computer screen. Such a discovery would revolutionize our understanding of infinity, and might even suggest that the universe, while incredibly vast, is ultimately finite. String theory, another approach to quantum gravity, suggests that our familiar three dimensions of space might be just a subset of a higher dimensional reality, where additional dimensions are curled up or compactified at every point in space. These extra dimensions could provide new ways for space to be finite, even if it appears infinite in our familiar three dimensions. The holographic principle, emerging from string theory, suggests that all the information contained in a volume of space can be encoded on its boundary, much like a hologram encodes three-dimensional information on a two-dimensional surface. This principle has led to the idea that our three-dimensional universe might actually be a projection from a two-dimensional boundary, raising profound questions about the nature of space and reality itself. But perhaps the most mind-bending possibility comes from the theory of eternal inflation, which we touched on earlier. This theory suggests that the rapid expansion that occurred in the first fraction of a second after the Big Bang, called inflation, didn't happen just once in our region of space, but is happening constantly throughout an infinite multiverse, creating new bubble universes, like soap bubbles, forming in an infinite cosmic bath. In this scenario, our entire observable universe, with all its galaxies, stars, and planets, would be just one bubble in an infinite sea of bubbles. Each bubble represents a separate universe with its own Big Bang, its own expansion, and potentially its own laws of physics. The space between bubbles would continue to inflate forever, creating room for infinitely many more universes to form. This eternal inflation would make the question of whether space is infinite almost trivial, because space wouldn't just be infinite. It would contain an infinite number of separate universes, each potentially infinite in its own right. It's like asking whether the ocean is wet when you're standing in the middle of an infinite sea of oceans. The theory of eternal inflation emerged from attempts to solve certain puzzles in cosmology, such as why our universe appears so uniform and flat on large scales. But it leads to consequences that are even more extraordinary than the problems it was designed to solve. It suggests that not only is our universe possibly infinite, but it's embedded within an even larger infinite structure, containing countless other universes. In this infinite multiverse, every possible universe that could exist does exist somewhere. Every possible version of the laws of physics, every possible arrangement of matter and energy, every possible story that could be told about cosmic evolution, all of these exist as physical realities in different bubble universes within the eternal inflation. This vision of reality is so vast and rich that it challenges our ability to comprehend it. Yet it emerges naturally from our best theories about the early universe and the nature of space and time. It's a reminder that the universe is far stranger and more wonderful than our everyday experience might suggest. But eternal inflation also brings its own set of puzzles, particularly the measure problem that we mentioned earlier. If every possible universe exists infinitely many times, how do you calculate the probability of any particular observation? It's like trying to determine the average height of people when you have an infinite number of people of every possible height. This problem has led to intense debates among cosmologists about whether eternal inflation is truly scientific or whether it's more of a mathematical curiosity. Some argue that if a theory can't make testable predictions, it's not really science, while others contend that the implications are so profound that we need to develop new ways of thinking about probability and prediction. Stephen Hawking, in his final work, attempted to address some of these challenges by proposing that the multiverse might be finite, after all, with only a limited number of possible universes emerging from eternal inflation. This would make the theory more testable and predictive, while still preserving the essential insight that our universe might be one of many. But regardless of whether the multiverse is finite or infinite, the basic question about our own universe remains. Does the space we inhabit extend forever in all directions, or does it curve back on itself in some finite but unbounded way? This question continues to drive research and capture imaginations around the world. The implications of either answer are profound and beautiful. If space is infinite, then we live in a cosmos of unlimited possibility, where every story that could be told is being lived somewhere in the vast expanse. If space is finite, then we inhabit a more intimate universe, where every region of space is ultimately connected to every other region through the topology of the cosmos. Both possibilities inspire a sense of wonder and humility about our place in the universe. Whether we're part of an infinite expanse or a finite but unbounded whole, we find ourselves in a cosmos that's far grander and more mysterious than our ancestors could have imagined. The search for answers continues with new instruments, new theories, and new ways of thinking about the fundamental nature of reality. Perhaps we'll eventually discover definitive evidence that space is infinite, or perhaps we'll find that it's finite but unbounded in ways that challenge our current understanding. Or perhaps, most intriguingly, we'll discover that the question itself needs to be reformulated, that our concepts of a finite and infinite space and time are too limited to capture the true nature of the cosmos. It wouldn't be the first time that scientific progress has required us to abandon our most basic assumptions about reality. But regardless of what we discover, the journey of exploration itself is part of what makes us human. The ability to stand beneath the star-filled sky and wonder about the ultimate nature of everything is one of our species' greatest achievements. It connects us to the cosmos that gave us birth and to the long chain of curious minds that have pondered these same questions throughout history. Whether space ends or goes on forever, we find ourselves here, now, in this moment of cosmic history, able to contemplate the very foundations of existence. And in a universe that might contain infinite copies of ourselves, this particular version of you is here, listening to these words, participating in humanity's greatest adventure, the quest to understand our place in the cosmos. As we drift deeper into this cosmic meditation, there's something wonderfully soothing about the way these profound questions seem to dissolve the boundaries between science and philosophy, between the measurable and the mystical. The universe, it seems, has a way of making poets out of physicists and philosophers out of anyone who gazes up at the night sky long enough. Consider for a moment the sheer audacity of what we're attempting to understand. Here we are, collections of atoms that were forged in the hearts of dying stars, organized into patterns complex enough to contemplate their own origins. And we're asking questions about the ultimate nature of everything that exists. It's simultaneously the most natural thing in the world and the most presumptuous. Yet somehow, through careful observation and mathematical reasoning, we've managed to constrain the possibilities and make educated guesses about infinity itself. The beauty of this cosmic detective story lies not just in the potential answers, but in the elegance of the questions themselves. When we ask whether space ends or goes on forever, we're really asking about the nature of existence, the meaning of boundaries, and the relationship between the finite and the infinite. These aren't just abstract mathematical concepts. They're fundamental aspects of reality that affect everything from the formation of galaxies to the evolution of consciousness. Think about how the question has evolved over the centuries. Ancient civilizations looked up at the same stars we see tonight and wondered about the edges of the world. Medieval scholars debated whether God could create a stone so heavy that even he couldn't lift it, grappling with the paradoxes of infinity in their own way. Renaissance thinkers like Giordano Bruno dared to imagine infinite worlds, paying the ultimate price for their cosmic vision. And now, modern cosmologists use billion-dollar instruments to peer into the deepest reaches of space and time, seeking answers to questions that have haunted humanity since we first learned to wonder. What strikes me as particularly beautiful is how each generation has brought its own tools and perspectives to bear on these eternal questions. The ancient Greeks used pure logic and geometric reasoning. Medieval scholars applied theological frameworks. Renaissance astronomers employed the first telescopes. Modern scientists harness the power of particle accelerators, space telescopes, and quantum computers. Yet the fundamental mystery remains, always just beyond our reach, like a horizon that recedes as we approach it. The cosmic microwave background has been particularly generous in revealing its secrets, but it's done so in whispers rather than shouts. The tiny temperature fluctuations in this ancient radiation tell us about the seeds that would grow into galaxies, but they speak in a language of statistics and probability rather than definitive declarations. When scientists say the universe appears to be flat, they're making a statement about geometry that's precise to within a fraction of a percent, yet it still leaves room for infinite possibilities. This precision is both humbling and inspiring. We can measure the curvature of space to extraordinary accuracy, but we cannot definitively say whether space extends forever. We can detect gravitational waves from colliding black holes billions of light years away, but we cannot see beyond the cosmic horizon that surrounds us. We can calculate the exact temperature of the cosmic microwave background to 6 decimal places, but we cannot answer the simple question of whether the universe has an edge. Perhaps this is as it should be. Perhaps some mysteries are meant to remain just beyond our grasp, not to frustrate us, but to inspire us. The question of cosmic infinity has driven centuries of scientific progress, leading to discoveries we never could have imagined. It's pushed us to develop new mathematical frameworks, build increasingly sophisticated instruments, and think in ways that challenge our most basic assumptions about reality. The search for cosmic topology has become a particularly elegant example of this scientific detective work. Scientists have developed ingenious methods to look for the signatures of a finite universe, searching for patterns in the cosmic microwave background that would indicate we're seeing the same region of space from different directions. It's like looking for echoes in a vast cathedral, listening for the subtle reverberations that would tell us about the shape and size of the cosmic architecture. They've also searched for what cosmologists call cosmic crystallography, looking for regular patterns in the distribution of galaxies that might indicate we're seeing the same structures repeated due to the topology of space. Imagine looking at a complex wallpaper pattern and trying to determine whether it repeats or extends infinitely in all directions. The challenge is that we can only see a small section of the pattern, and we have to infer the nature of the whole from this limited sample. So far, these searches have come up empty, but that doesn't necessarily mean the universe is infinite. It could simply mean that if the universe is finite, it's so large that the repeating pattern lies beyond our observable horizon. It's like trying to determine whether you're standing on a sphere by examining only a small patch of ground beneath your feet. If the sphere is large enough, that patch will appear perfectly flat, giving no hint of the underlying curvature. The expansion of the universe adds another layer of poetry to this cosmic mystery. When Edwin Hubble first discovered that distant galaxies are receding from us, he revealed something profound about the nature of space itself. Space isn't just a passive container for matter and energy. It's an active participant in cosmic evolution, stretching and growing in ways that affect everything within it. This expansion doesn't necessarily tell us whether space is finite or infinite, but it does create a dynamic situation where new regions of space are constantly coming into view, while others recede beyond our ability to observe them. It's like standing on the shore of an infinite ocean where new waves are constantly arriving, while others disappear beyond the horizon. The ocean itself might be infinite, but our ability to observe it is always limited by the horizon that surrounds us. The discovery that this expansion is accelerating, driven by the mysterious dark energy, has added yet another chapter to our cosmic story. Dark energy appears to be a property of empty space itself, causing regions of space to expand at an ever-increasing rate. This acceleration creates a cosmic event horizon, beyond which galaxies recede from us faster than light can travel, forever hidden from our view. Recent observations have suggested that dark energy might not be constant, but could be evolving over time, weakening or strengthening in ways that could dramatically alter the universe's future evolution. If dark energy continues to weaken, the expansion might eventually slow down, stop, and reverse, leading to a big crunch where all of space collapses back into a singularity. Alternatively, if dark energy strengthens over time, it could lead to an even more dramatic scenario, where the expansion accelerates so violently that it tears apart the very fabric of space-time itself. These possibilities remind us that the question of spatial infinity is intimately connected to questions about time and the ultimate fate of everything. Even if space goes on forever, it's not a static infinity, but a dynamic, evolving one that changes in ways we're only beginning to understand. The universe has a history, and that history is still being written in the language of expanding space and evolving dark energy. But perhaps the most fascinating aspect of this cosmic puzzle is how it connects to our everyday experience of wonder and curiosity. The question of whether space is infinite isn't just an abstract problem for professional cosmologists. It's a question that touches something deep in the human psyche. We're pattern-seeking creatures, living in a universe that seems to be structured by mathematical relationships of extraordinary beauty and complexity. When we contemplate the possibility of infinite space, we're not just thinking about geometry and topology, we're thinking about possibility itself. What does it mean to live in a universe where every possible story could be unfolding somewhere in the vast expanse? How do we find meaning and purpose in a cosmos that might contain infinite copies of ourselves making every conceivable choice? These questions have profound implications for how we think about identity, consciousness, and our place in the cosmic order. If there are infinite versions of ourselves scattered throughout infinite space, what makes this particular version special? Are we unique individuals, or are we just one note in an infinite symphony of existence? The mathematical frameworks we use to explore these possibilities are themselves things of quiet beauty. The equations of general relativity, with their elegant description of curved space-time, provide the language for discussing cosmic geometry. The principles of quantum mechanics, with their emphasis on probability and uncertainty, offer insights into the nature of reality at the smallest scales. The theories of inflation and eternal inflation, with their predictions of multiple universes and infinite possibilities, push the boundaries of what we can conceive and test. Yet for all their mathematical sophistication, these theories still leave us with fundamental mysteries. We don't know whether the universe is finite or infinite. We don't know whether we live in a multiverse or a single cosmos. We don't know whether space has an edge or extends forever in all directions. These are questions that may ultimately be unanswerable, not because of limitations in our instruments or theories, but because of the fundamental nature of infinity itself. The development of new technologies continues to push the boundaries of what we can observe and measure. Advanced gravitational wave detectors are beginning to probe the deepest structures of space-time, potentially revealing signatures of cosmic topology or the infinite nature of space. Future space telescopes will map the cosmic microwave background with unprecedented precision, searching for subtle patterns that might reveal the ultimate geometry of the cosmos. Quantum computers, still in their infancy, might eventually allow us to simulate cosmic evolution in ways that could shed light on the nature of infinite space. Artificial intelligence systems are already helping astronomers analyze vast datasets from cosmic surveys, looking for patterns that might reveal the topology of space or the signatures of infinite structure. But technology alone won't answer these questions. We also need new ways of thinking about infinity, probability, and the nature of existence itself. The measure problem in eternal inflation, for instance, requires us to develop new mathematical frameworks for dealing with infinite quantities. The implications of cosmic infinity for consciousness and identity challenge us to think in ways that bridge science and philosophy. Perhaps most importantly, we need to maintain a sense of wonder and humility about these cosmic mysteries. The universe has a way of surprising us, of revealing truths that are stranger and more beautiful than anything we could have imagined. Every major discovery in cosmology has forced us to abandon cherished assumptions about the nature of reality. The discovery of cosmic expansion overturned the idea of a static universe. The cosmic microwave background revealed the hot, dense origins of the cosmos. Dark energy showed us that the universe's expansion is accelerating for reasons we don't fully understand. What surprises await us as we continue to probe the question of cosmic infinity? Perhaps we'll discover that space is indeed infinite, stretching on forever in all directions, and containing every possible story that could be told. Perhaps we'll find that it's finite but unbounded, curving back on itself in ways that make every region of space ultimately connected to every other region. Or perhaps we'll discover that the question itself needs to be reformulated, that our concepts of a finite and infinite space are too limited to capture the true nature of the cosmos. The journey of exploration itself is part of what makes us human. The ability to stand beneath the star-filled sky and wonder about the ultimate nature of everything is one of our species' greatest achievements. It connects us to the cosmos that gave us birth and to the long chain of curious minds that have pondered these same questions throughout history. Whether space ends or goes on forever, we find ourselves here now, in this moment of cosmic history, able to contemplate the very foundations of existence. In a universe that might contain infinite copies of ourselves, this particular version of you is here, listening to these words, participating in humanity's greatest adventure, the quest to understand our place in the cosmos. And perhaps that's the most beautiful part of all. In contemplating infinity, we discover something profound about ourselves. We are finite beings capable of conceiving of the infinite, temporary patterns of matter and energy that can contemplate eternity. We are the universe becoming aware of itself, asking questions about its own nature, and seeking answers among the stars. The question of whether space ends or goes on forever may never be definitively answered, but the search for that answer has already given us something invaluable, a deeper appreciation for the mystery and beauty of existence itself. In our quest to understand the cosmos, we've discovered that we are not separate from it, but part of it, woven into the very fabric of space and time that we seek to comprehend. So as we drift through this cosmic meditation, let us hold both possibilities lightly in our minds. Whether space is finite or infinite, bounded or boundless, it has given rise to stars and planets, to life and consciousness, to the very capacity for wonder that allows us to ask these questions. In the end, perhaps that's the most profound truth of all, that a universe capable of producing beings who can contemplate infinity is itself infinite in its capacity to inspire awe and wonder. The stars above us tonight are the same stars that have inspired countless generations of dreamers and thinkers. They have witnessed the rise and fall of civilizations, the birth and death of species, the slow evolution of consciousness, from simple matter to complex minds capable of asking the deepest questions about existence. And they will continue to shine long after we are gone, illuminating the path for future generations of cosmic explorers. In their light, we find not just the photons that travelled billions of years to reach our eyes, but the promise that the quest for understanding will continue. Whether space ends or goes on forever, the human spirit of inquiry seems infinite in its own right. always reaching toward new horizons, always seeking to push the boundaries of the known into the vast realm of the unknown. And in that reaching, in that eternal quest for understanding, we find perhaps the closest thing to infinity that we can truly know, the infinite capacity of consciousness to wonder, to question, and to find beauty in the very act of seeking answers to the deepest mysteries of existence. So here we are, drifting through the cosmic sea of possibilities, and I find myself wondering about something rather beautiful. What would it actually feel like to live in a universe where every possible story is being told somewhere in the vast expanse? It's a question that sits at the intersection of physics and poetry, mathematics and meaning, and it reveals something profound about how the search for cosmic infinity has changed not just our understanding of space, but our understanding of ourselves. When we contemplate the possibility that space goes on forever, we're not just thinking about distances and geometries, we're thinking about the very nature of existence itself. If the universe is truly infinite, then every arrangement of matter and energy that could possibly exist does exist somewhere in the boundless expanse. Every story that could be told is being lived. Every dream that could be dreamed is someone's reality. This isn't just a poetic metaphor, it's a direct consequence of the mathematics of infinity. In an infinite universe with finite possibilities for how matter can arrange itself within any given volume, every possible configuration must repeat infinitely often. It's like having an infinite library that contains every possible book, every possible sentence, every possible thought that could ever be written down. The implications are both thrilling and slightly overwhelming. Somewhere in the infinite expanse, there's a version of you who decided to become a marine biologist instead of whatever path brought you here tonight. There's another version who learned to play the violin beautifully, and yet another who chose to live in a completely different part of the world. Each of these versions is living their own, complete, rich, meaningful life, making their own choices and discoveries. But it goes deeper than just alternate versions of familiar stories. In an infinite universe, there would be entire worlds where the history of life unfolded differently. Planets where consciousness emerged from silicon-based chemistry rather than carbon. Worlds where the dinosaurs never went extinct and developed their own sophisticated civilizations, complete with art, music, and perhaps even their own theories about cosmic infinity. There would be regions where the fundamental constants of nature are slightly different, allowing for entirely alien forms of physics and chemistry. Worlds where gravity is a bit weaker, where light behaves differently, where time itself might flow at a different pace. Each variation would create its own unique flavor of reality, its own possibilities for complexity and beauty. The mathematician Max Tegmark has explored these implications in fascinating detail. He's calculated that if the universe is infinite and matter is distributed roughly uniformly throughout it, then your nearest identical copy would be located at a distance so vast that it defies comprehension. We're talking about numbers with more digits than there are atoms in the observable universe. Yet in an infinite cosmos, such distances become almost quaint, just another measurement in the endless catalogue of possibilities. This vision of infinite diversity raises profound questions about the nature of identity and uniqueness. If there are infinite versions of yourself scattered throughout infinite space, what makes this particular version special? Are you unique, or are you just one note in an infinite symphony of existence? It's a question that philosophers have grappled with for centuries, but the possibility of cosmic infinity gives it a new urgency and depth. Some find this prospect unsettling, as if the existence of infinite copies somehow diminishes the value of individual experience. But I think there's something deeply beautiful about it. In an infinite universe, every moment of joy, every act of kindness, every creative breakthrough exists not just once but infinitely many times. Love doesn't become less meaningful because it's infinite. it becomes more precious because it's part of an endless tapestry of connection and care. The search for evidence of this infinite diversity has become one of the most intriguing aspects of modern cosmology. Scientists are looking for subtle signatures in the cosmic microwave background that might reveal the infinite nature of space. They're searching for patterns that could indicate we're seeing the same cosmic structures from different angles, like reflections in a hall of mirrors that extends forever in all directions. Advanced computer simulations are helping us understand what an infinite universe might actually look like. These models suggest that while matter would be distributed roughly uniformly on the larger scales, there would be incredible diversity in the details. Clusters of galaxies would form in patterns that never exactly repeat, creating an infinite variety of cosmic neighborhoods, each with its own unique character and history. The implications extend beyond just the arrangement of matter and energy. If consciousness is a natural consequence of sufficient complexity, then an infinite universe would contain infinite minds, each with its own perspective on existence. There would be civilizations so advanced that their technology would seem like magic to us, and others just beginning to ask the same questions about cosmic infinity that we're exploring tonight. Some of these minds might have already solved the riddle of whether space is infinite. They might have developed instruments capable of detecting the global topology of the universe, or mathematical frameworks that definitively prove the nature of cosmic geometry. In an infinite universe, every possible discovery has already been made somewhere. Every possible theory has been developed and tested. But this raises another beautiful paradox. If infinite minds have already discovered everything there is to know, why do we still find ourselves wondering about these questions? Perhaps it's because the joy of discovery isn't diminished by the fact that others have made the same discoveries. Each mind that encounters a new truth experiences the wonder of understanding for the first time, regardless of how many times that same truth has been discovered elsewhere. The possibility of infinite consciousness also raises questions about the nature of meaning and purpose. If every possible story is being lived somewhere in the infinite expanse, what gives any particular story its significance? This is where the beauty of the infinite universe becomes most apparent. Meaning doesn't come from uniqueness, it comes from the quality of experience itself. The love you feel for the people in your life isn't diminished by the fact that infinite other versions of love exist somewhere in the cosmos. The beauty of a sunset isn't less moving because infinite other sunsets are painting infinite other skies. The sense of wonder you feel when contemplating these cosmic mysteries isn't less valuable because infinite other minds are having similar thoughts. In fact, the infinite nature of space might make each experience more precious, not less. In a finite universe, every moment of joy, every act of creativity, every breakthrough in understanding would be unique but temporary. In an infinite universe, these precious experiences become part of an eternal tapestry, forever woven into the fabric of existence itself. The search for cosmic infinity has also revealed something beautiful about the nature of scientific inquiry itself. The questions we're asking about the extent of space are fundamentally questions about the nature of reality, and they connect us to a tradition of wonder that stretches back to the earliest human civilizations. Every culture that has ever looked up at the night sky has wondered about the boundaries of existence, the nature of the cosmos, and our place within it. Modern cosmology has given us tools to explore these questions with unprecedented precision, but it hasn't diminished their mystery or their capacity to inspire awe. If anything, the more we learn about the universe, the more wonderful it becomes. The possibility that space might be infinite isn't just a scientific hypothesis, it's a doorway to contemplating the deepest questions about existence, consciousness, and the nature of reality itself. The cosmic microwave background continues to whisper its secrets to us, revealing the geometry of space with ever-increasing precision. Each new measurement brings us closer to understanding whether we live in a finite or infinite cosmos, but it also reveals new mysteries, new questions to explore. The universe seems to delight in showing us how much we still don't know, how many wonders remain to be discovered. Dark energy, that mysterious force driving the accelerating expansion of space, adds another layer of complexity to our cosmic story. If dark energy continues to strengthen over time, it could lead to a scenario where the expansion of space accelerates so dramatically that it tears apart the very fabric of space-time itself. In such a universe, the question of whether space is infinite becomes moot because space itself would be destroyed in what cosmologists call the Big Rip. But if dark energy weakens over time, the expansion might slow down, stop, and reverse, leading to a big crunch where all of space collapses back into a singularity. Recent observations suggesting that dark energy might indeed be evolving over time have added urgency to these questions. The ultimate fate of space itself might depend on the precise nature of this mysterious force that we're only beginning to understand. The theory of eternal inflation offers perhaps the most mind-bending possibility of all. If this theory is correct, then our entire observable universe is just one bubble in an infinite sea of bubbles, each representing a separate universe with its own Big Bang, its own expansion, and potentially its own laws of physics. The space between these bubbles would continue to inflate forever, creating room for infinitely many more universes to form. In this scenario, the question of whether our particular universe is infinite becomes just one small part of a much larger question about the nature of the multiverse itself. Even if our universe is finite, it would be embedded within an infinite structure containing countless other universes, each with its own possibilities for complexity, consciousness, and wonder. Stephen Hawking, in his final work, attempted to make sense of this infinite multiverse by proposing that it might be more constrained than previously thought. He suggested that the number of possible universes emerging from eternal inflation might be finite, making the theory more testable and predictive. This would still leave us with the question of whether our particular universe is infinite, but it would place that question within a more manageable cosmic context. The measure problem in eternal inflation continues to challenge our understanding of probability and prediction in an infinite multiverse. If every possible universe exists infinitely many times, how do we calculate the likelihood of any particular observation? It's like trying to determine the average value of an infinite set of numbers, where every possible value occurs infinitely often. This isn't just a mathematical puzzle, it's a fundamental challenge to the scientific method itself. Science depends on our ability to make predictions and test them against observations. But in an infinite multiverse where every possible observation occurs infinitely many times, the usual rules of probability seem to break down. New mathematical frameworks are being developed to address these challenges, but they're still in their infancy. The holographic principle, emerging from string theory, suggests another way of thinking about cosmic infinity. This principle holds that all the information contained in a volume of space can be encoded on its boundary, like a hologram that contains three-dimensional information on a two-dimensional surface. If this principle is correct, then our three-dimensional universe might actually be a projection from a two-dimensional boundary, raising profound questions about the nature of space and reality itself. Loop quantum gravity, another approach to understanding the fundamental nature of space-time, suggests that space itself might be quantized, made up of discrete units rather than being continuous. If space is indeed quantized, then there might be a smallest possible unit of space, just as there's a smallest unit of electric charge. This could mean that while space appears continuous at large scales, it's actually made up of tiny, discrete building blocks. Such a discovery would revolutionize our understanding of infinity. A quantized universe might be incredibly vast but ultimately finite, like a cosmic computer screen made up of an enormous but finite number of pixels. the implications for consciousness, identity, and meaning would be profound, as it would suggest that there might be a finite number of possible states for any given region of space. The development of quantum computers is beginning to offer new ways of exploring these possibilities. These machines, which harness the strange properties of quantum mechanics to perform calculations, might eventually allow us to simulate cosmic evolution in ways that could shed light on the nature of infinite space. They might help us understand how consciousness emerges from complex arrangements of matter, or how the laws of physics themselves might vary in different regions of an infinite multiverse. Artificial intelligence systems are already helping astronomers analyze vast datasets from cosmic surveys, looking for patterns that might reveal the topology of space or the signatures of infinite structure. Machine learning algorithms can process information from millions of galaxies, searching for correlations that might indicate we're seeing the same cosmic structures from different angles. But technology alone won't answer these questions. We also need new ways of thinking about infinity, consciousness, and the nature of existence itself. The questions we're asking about cosmic infinity push the boundaries of human understanding, challenging us to think in ways that bridge science and philosophy, mathematics and meaning. Perhaps most importantly, we need to maintain a sense of wonder and humility about these cosmic mysteries. The universe has a way of surprising us, of revealing truths that are stranger and more beautiful than anything we could have imagined. Every major discovery in cosmology has forced us to abandon cherished assumptions about the nature of reality, and the quest to understand cosmic infinity will likely do the same. The beauty of this cosmic journey lies not just in the potential answers but in the questions themselves. When we ask whether space ends or goes on forever, we're participating in humanity's greatest adventure, the quest to understand our place in the cosmos. We're using the spark of consciousness that emerged from billions of years of cosmic evolution to contemplate the very cosmos that gave us birth. Whether space is finite or infinite, whether we live in one universe or infinitely many, we find ourselves here, now, in this moment of cosmic history, able to wonder about the ultimate nature of everything. In a universe that might contain infinite copies of ourselves, this particular version of you is here, listening to these words, participating in this ancient and eternal quest for understanding. And perhaps that's the most beautiful mystery of all. In contemplating infinity, we discover something profound about ourselves. We are finite beings capable of conceiving of the infinite, temporary patterns of matter and energy that can contemplate eternity. We are the universe becoming aware of itself, asking questions about its own nature, and seeking answers among the stars. The question of whether space ends or goes on forever may never be definitively answered, but the search for that answer has already given us something invaluable, a deeper appreciation for the mystery and beauty of existence itself. In our quest to understand the cosmos, we've discovered that we are not separate from it but part of it, woven into the very fabric of space and time that we seek to comprehend. So as we continue to drift through this cosmic meditation, let us hold both possibilities lightly in our minds. Whether space is finite or infinite, bounded or boundless, it has given rise to stars and planets, to life and consciousness, to the very capacity for wonder that allows us to ask these questions. In the end, perhaps that's the most profound truth of all, that a universe capable of producing beings who can contemplate infinity is itself infinite in its capacity to inspire awe and wonder. The stars above us tonight have witnessed the rise and fall of civilizations, the birth and death of species, the slow evolution of consciousness from simple matter to complex minds capable of asking the deepest questions about existence. They will continue to shine long after we are gone, illuminating the path for future generations of cosmic explorers who will carry forward this eternal quest for understanding. In their ancient light, we find not just the photons that travel billions of years to reach our eyes, but the promise that the human spirit of inquiry will continue. Whether space ends or goes on forever, our capacity to wonder, to question, and to find beauty in the very act of seeking answers seems itself infinite, always reaching toward new horizons, always pushing the boundaries of the known into the vast realm of the unknown. And so we find ourselves drifting towards something rather remarkable. Because while we've been contemplating the vastness of space and the possibility of infinite worlds, the most beautiful discovery might be the simplest one of all. That regardless of whether space ends or goes on forever, we are here now, in this moment, capable of asking these questions at all. Think about it for a moment. You are a temporary arrangement of atoms that were forged in the hearts of dying stars, organized into patterns so complex that they can contemplate their own existence. You are, quite literally, made of star stuff that has learned to wonder about stars. And that wonder, that capacity to look up at the night sky and ask whether it goes on forever, is perhaps the most extraordinary thing in the entire cosmos. The search for cosmic infinity has revealed something profound about the nature of consciousness itself. We are not passive observers of the universe, we are the universe observing itself. Through billions of years of evolution, atoms have arranged themselves into patterns capable of mathematics, poetry, love, and the deep yearning to understand whether space has boundaries or stretches on without end. Every telescope we build, every equation we solve, every late-night conversation about the nature of existence is the cosmos reaching towards self-understanding through us. When we map the cosmic microwave background, we are ancient starlight examining its own origins. When we calculate the curvature of space, we are the geometry of the universe discovering its own shape. This realization transforms the entire question of cosmic infinity from something abstract and distant into something intimately personal. Whether space is finite or infinite, it has given rise to consciousness. And consciousness has given rise to the question itself. There's something beautifully circular about this, like a cosmic conversation that the universe is having with itself. The medieval mystics used to speak of the universe as a book written in the language of mathematics, and we are slowly learning to read that book, letter by letter, equation by equation, discovery by discovery. Each new insight into the nature of space and time is like turning another page in an infinite story that we are simultaneously reading and writing. But here's what I find most comforting about this cosmic journey. We don't need to solve the riddle of infinity to find meaning in our existence. The very fact that we can ask these questions, that we can contemplate the possibility of infinite space and infinite possibilities, is itself a kind of miracle. Whether the universe is finite or infinite, it has produced beings capable of wonder. The ancient philosophers who first pondered these questions under star-filled skies knew something that we sometimes forget in our age of sophisticated instruments and complex theories. They understood that the greatest mysteries are not problems to be solved, but wonders to be contemplated. The question of whether space ends or goes on forever is not just a scientific puzzle, it's an invitation to participate in the grand conversation between mind and cosmos. When Johannes Kepler wondered why the night sky is dark despite the possibility of infinite stars, he was not just solving a mathematical problem, he was engaging in a form of cosmic meditation, using his mind to explore the deepest structures of reality. When Giordano Bruno imagined infinite worlds orbiting infinite suns, he was not just proposing a scientific theory, he was opening his consciousness to the possibility of unlimited wonder. And when modern cosmologists study the cosmic microwave background, searching for signs of cosmic topology, they are continuing this ancient tradition of using human consciousness to explore the very foundations of existence. Each measurement, each calculation, each theoretical breakthrough is a moment of contact between mind and cosmos. The beauty of this search lies not just in what we might discover, but in the searching itself. Every generation of cosmic explorers has found new wonders to contemplate, new mysteries to ponder, new questions to ask about the nature of everything. The universe seems to delight in revealing just enough of its secrets to inspire us to keep looking, while always maintaining an air of beautiful mystery. Think about how far we've come, from the ancient belief in a small, finite cosmos centered on Earth, to our modern understanding of an expanding universe that might stretch on forever, filled with dark matter and dark energy, and possibly infinite copies of ourselves. Each step in this journey has revealed that the universe is far stranger and more wonderful than we ever imagined. Yet with each new discovery, we also discover how much we still don't know. The cosmic microwave background has told us that the universe is geometrically flat, but it hasn't told us whether space is truly infinite. The acceleration of cosmic expansion has revealed the existence of dark energy, but we still don't understand what it actually is. The possibility of eternal inflation suggests we might live in an infinite multiverse, but we can't test this theory directly. This is the beautiful paradox of cosmic exploration. The more we learn, the more we realize how much remains to be discovered. It's like standing at the edge of an infinite ocean of knowledge, where each wave that reaches the shore brings new treasures while revealing the vast depths that still lie unexplored. The question of whether space ends or goes on forever has led us to discoveries we never could have anticipated. The expansion of the universe, dark energy, quantum mechanics, general relativity, all of these emerge from humanity's deep desire to understand the nature of space and time. And each discovery has opened new avenues of wonder, new questions to explore. But perhaps the most profound discovery is that we are not separate from the cosmos we seek to understand. We are part of it, woven into the very fabric of space and time that we study. When we contemplate the possibility of infinite space, we are space contemplating itself. When we wonder about the ultimate fate of the universe, we are the universe wondering about its own destiny. This perspective transforms our relationship with existence itself. We are not isolated beings struggling to understand an alien cosmos. We are expressions of the cosmos coming to know itself through us. The atoms in our bodies, the thoughts in our minds, the capacity for wonder that allows us to ask these questions. All of these are cosmic phenomena, as natural and inevitable as the formation of stars or the expansion of space. The search for cosmic infinity has also revealed something beautiful about the nature of human collaboration. When astronomers in Chile observe distant galaxies, their measurements are combined with data from space telescopes orbiting Earth. Theoretical physicists in universities around the world develop mathematical frameworks to interpret these observations, and citizen scientists contribute their own processing power to help analyze the vast datasets. This global collaboration in the search for cosmic truth is itself a kind of infinity, a boundless network of minds working together to understand the nature of space and time. It's a reminder that while we may be finite beings, our collective capacity for discovery and understanding seems to grow without limits. The development of new technologies continues to expand our ability to explore these cosmic mysteries. Gravitational wave detectors are opening new windows into the nature of spacetime itself. Quantum computers may eventually allow us to simulate cosmic evolution in ways that could shed light on the infinite nature of space. Artificial intelligence systems are already helping us analyze cosmic data in ways that would be impossible for human minds alone. But technology is not the only tool we need to explore these questions. We also need imagination, intuition, and the willingness to contemplate possibilities that challenge our most basic assumptions about reality. The greatest breakthroughs in cosmology have often come from scientists who are willing to think in radically new ways, to consider possibilities that seemed impossible at first glance. Einstein's insight that space and time are not separate but form a unified spacetime that can be curved by matter and energy was not just a mathematical discovery, it was an act of imagination that transformed our understanding of the cosmos. Hubble's realization that the universe is expanding came from carefully observing the light from distant galaxies, but it also required the conceptual leap to imagine that space itself could be growing. The possibility of cosmic infinity requires a similar leap of imagination. It asks us to consider that the universe might be so vast that it contains every possible story, every possible arrangement of matter and energy, every possible form of consciousness and meaning. It's a vision that challenges our everyday experience of uniqueness and limitation. Yet there's something deeply comforting about this possibility. If the universe is infinite, then every moment of beauty, every act of love, every breakthrough in understanding becomes part of an eternal tapestry that can never be destroyed. The laughter of children, the companionship of friends, the quiet satisfaction of understanding something new about the cosmos. All of these precious experiences would exist not just once, but infinitely many times. This doesn't diminish their value, it amplifies it. In an infinite universe, love doesn't become less meaningful because it's infinite. It becomes more precious because it's woven into the very fabric of existence itself. Every sunset, every piece of music, every moment of wonder at the night sky becomes part of an infinite symphony of experience. The question of whether space ends or goes on forever may never be definitively answered, but the search for that answer has already given us something invaluable, a deeper appreciation for the mystery and beauty of existence itself. In our quest to understand the cosmos, we've discovered that we are not separate from it but part of it, participants in the universe's ongoing journey of self-discovery. As we drift toward the end of our cosmic meditation, let me ask you once more, where are you listening from tonight, and what do you see when you look up at the sky? Whether you're beneath a canopy of stars or city lights, whether you're in a bustling metropolis or a quiet countryside, you're part of this vast cosmic story. The photons reaching your eyes tonight have traveled across unimaginable distances, carrying information about the nature of space and time. The atoms in your body were forged in stellar furnaces and scattered across space by cosmic explosions. You are, quite literally, made of the same stuff as the stars you see above you. This connection between you and the cosmos is not just poetic, it's physical, real, measurable. The calcium in your bones, the iron in your blood, the carbon in your cells, all of these elements were created in the hearts of dying stars and dispersed through space to eventually become part of you. You are star stuff that has learned to wonder about stars. And in that wonder, in that capacity to contemplate the infinite, you find perhaps the most beautiful aspect of existence itself. Consciousness is the universe's way of experiencing itself, of asking questions about its own nature, of finding meaning and beauty in the vast expanse of space and time. Whether space ends or goes on forever, whether we live in one universe or infinitely many, we find ourselves here, now, in this moment of cosmic history, able to participate in this ancient quest for understanding. We are the universe becoming aware of itself through us, and that awareness, that capacity for wonder, is itself a kind of infinity. The stars above you tonight are the same stars that have inspired countless generations of dreamers and thinkers. They have witnessed the rise and fall of civilizations, the birth and death of species, the slow evolution of consciousness, from simple matter to complex minds capable of asking the deepest questions about existence. They will continue to shine long after we are gone, illuminating the path for future generations of cosmic explorers who will carry forward this eternal quest for understanding. In their ancient light, we find not just the photons that travelled billions of years to reach our eyes, but the promise that the human spirit of inquiry will continue. Whether space ends or goes on forever, our capacity to wonder, to question, to find beauty in the very act of seeking answers seems itself infinite, always reaching toward new horizons. always pushing the boundaries of the known into the vast realm of the unknown. And perhaps that's the most profound truth of all. In contemplating infinity, we discover something infinite within ourselves, the boundless capacity for wonder that allows us to ask these questions in the first place. Whether the universe is finite or infinite, it has given rise to consciousness, and consciousness has given rise to the eternal quest to understand. So as you drift off to sleep tonight, whether space ends or goes on forever, know that you're part of something magnificent. You're the cosmos contemplating itself through the spark of consciousness that emerged from billions of years of cosmic evolution. And in that contemplation, in that wonder, you touch something infinite and eternal. The question of whether space ends or goes on forever may remain forever beyond our reach, but the search for that answer has already given us the most precious gift of all, the ability to wonder, to question, to find beauty and meaning in the vast, mysterious cosmos that we call home. Sweet dreams, fellow traveller, wherever and whenever you are. And so here we are, drifting through this cosmic meditation like leaves on an infinite autumn breeze. And I find myself thinking about something rather beautiful. The way this question has evolved through human history, like a river that begins as a small spring in the mountains and gradually becomes a mighty current flowing toward the sea. The ancient Greeks, with their love of geometry and logical reasoning, were among the first to really grapple with the concept of infinity. They discovered that numbers themselves could go on forever, that you could always add one more to any number you could think of. But when it came to physical space, they were more cautious. Aristotle, in particular, argued that the material world had to be finite, because infinity seemed too abstract, too removed from the tangible reality of stones and trees and flowing water. Yet even then there were those who dared to imagine something grander. The atomists, like Democritus, proposed that space was filled with an infinite number of indivisible particles moving through an infinite void. It was a radical idea that suggested the universe might be far larger and more complex than anyone had previously imagined, though they lacked the tools to test such bold hypotheses. The medieval period brought its own unique perspective to these questions. Scholars like Thomas Aquinas wrestled with the theological implications of infinity. Could God create an infinite universe? And if so, what would that mean for human souls and divine purpose? They developed sophisticated arguments about the nature of infinity that blended Aristotelian logic with Christian theology, creating frameworks that would influence thinking for centuries to come. But it was the Renaissance that truly opened the floodgates of cosmic imagination. When Nicholas Copernicus proposed that Earth was not the centre of the universe, but merely one planet orbiting the Sun, he didn't just relocate our cosmic address. He fundamentally changed how we think about space itself. If Earth wasn't special, then perhaps the universe was far larger than anyone had dared to imagine. Giordano Bruno took this insight and ran with it in the most spectacular way imaginable. He proposed not just that the universe was infinite, but that it was filled with infinite worlds, each potentially harbouring its own forms of life. It was a vision so radical, so threatening to the established order, that it cost him his life. But his ideas planted seeds that would eventually bloom into our modern understanding of cosmic vastness. The scientific revolution brought new tools and new ways of thinking about these ancient questions. Galileo's telescope revealed moons orbiting Jupiter and the phases of Venus, proving that the cosmos was far more complex and dynamic than anyone had imagined. Kepler's laws of planetary motion showed that the heavens followed mathematical rules that could be discovered and understood through careful observation. Newton's law of universal gravitation provided a framework for understanding how matter behaves across vast distances, but it also raised new questions about the nature of space itself. If gravity acts instantaneously across infinite distances, then space must be something more than just empty nothingness. It must have structure, properties that allow forces to propagate through it. The 19th century brought even more dramatic changes to our cosmic perspective. When Edwin Hubble discovered that distant galaxies are moving away from us, he revealed that the universe is not static but expanding, growing larger with each passing moment. This discovery transformed the question of cosmic infinity from a philosophical puzzle into an observational challenge. If the universe is expanding, then it must have had a beginning, a moment when all of space and time emerged from some initial state. This became known as the Big Bang theory, and it suggested that while space might be infinite now, it had a finite age and a finite history. It was a profound shift in thinking that connected the question of spatial infinity to the nature of time itself. The 20th century brought quantum mechanics and relativity, two revolutionary theories that completely transformed our understanding of space and time. Einstein showed that space and time are not separate, but form a unified space-time that can be curved by matter and energy. Quantum mechanics revealed that space itself might be quantized, made up of discrete units rather than being perfectly continuous. These discoveries opened new avenues for exploring cosmic infinity. Loop quantum gravity suggests that space might be made up of tiny discrete building blocks, like pixels on a cosmic computer screen. If this is true, then the universe might be incredibly vast, but ultimately finite, containing a finite number of these fundamental units of space. String theory proposes that our familiar three dimensions of space might be just a subset of a higher dimensional reality, where additional dimensions are curled up at every point in familiar space. These extra dimensions could provide new ways for space to be finite, even if it appears infinite in our everyday experience. The holographic principle, emerging from string theory, suggests that all the information contained in a volume of space can be encoded on its boundary. Much like a hologram encodes three-dimensional information on a two-dimensional surface. If this principle is correct, then our three-dimensional universe might actually be a projection from a two-dimensional boundary. These theoretical developments have been accompanied by increasingly sophisticated observations. The cosmic microwave background has revealed the universe to be geometrically flat to extraordinary precision. But flatness alone doesn't tell us whether space is infinite or finite. A flat universe could extend forever, like an infinite sheet of paper, or it could wrap around itself, like a cosmic donut. The search for cosmic topology has become one of the most elegant detective stories in modern science. Astronomers are looking for repeating patterns in the cosmic microwave background or duplicate images of galaxies that would indicate we're seeing the same cosmic structures from different directions due to the wrapped geometry of space. Gravitational wave detectors have opened an entirely new window into the nature of spacetime itself. These instruments can detect ripples in the fabric of space caused by colliding black holes or neutron stars, potentially revealing information about the global structure of the universe that was previously hidden from view. Dark matter and dark energy have added new layers of mystery to our cosmic story. These invisible components make up about 95% of the universe, yet we know remarkably little about their true nature. Understanding them better might reveal whether they're consistent with an infinite universe, or whether they point towards some kind of cosmic boundary. The possibility of eternal inflation suggests that our observable universe might be just one bubble in an infinite sea of inflating space, where new universes are constantly being created through quantum fluctuations. In this scenario, the question of whether our particular universe is infinite becomes just one small part of a much larger question about the nature of the multiverse itself. Recent observations have suggested that dark energy might not be constant, but could be evolving over time, weakening or strengthening in ways that could dramatically alter the universe's future evolution. If dark energy continues to weaken, the expansion might eventually slow down, stop, and reverse, leading to a big crunch where all of space collapses back into a singularity. Alternatively, If dark energy strengthens over time, it could lead to an even more dramatic scenario where the expansion accelerates so violently that it tears apart the very fabric of space-time itself, creating what cosmologists call a big rip. In such a scenario, the question of whether space is infinite becomes moot because space itself would be destroyed. The development of quantum computers is beginning to offer new ways of exploring these cosmic mysteries. These machines, which harness the strange properties of quantum mechanics to perform calculations, might eventually allow us to simulate cosmic evolution in ways that could shed light on the nature of infinite space. Artificial intelligence systems are already helping astronomers analyze vast datasets from cosmic surveys, looking for patterns that might reveal the topology of space or the signatures of infinite structure. Machine learning algorithms can process information from millions of galaxies, searching for correlations that might indicate we're seeing the same cosmic structures from different angles. But technology alone won't answer these questions. We also need new ways of thinking about infinity, probability, and the nature of existence itself. The measure problem in eternal inflation, for instance, requires us to develop new mathematical frameworks for dealing with infinite quantities. The implications of cosmic infinity extend far beyond physics and into fundamental questions about consciousness, identity, and meaning. If the universe is infinite, then every possible arrangement of matter and energy exists somewhere in the vast expanse. Every story that could be told is being lived. Every dream that could be dreamed is someone's reality. This raises profound questions about the nature of uniqueness and individual identity. If there are infinite copies of ourselves scattered throughout infinite space, making slightly different choices and living slightly different lives, what does that mean for personal responsibility, moral agency, and the meaning of existence itself? Some philosophers have argued that infinite possibilities make individual choices meaningless because every possible choice is made by someone, somewhere in the infinite expanse. But others contend that this makes each choice more significant because it's part of an infinite moral landscape where every possible outcome is explored. The concept of infinite consciousness also challenges our understanding of what it means to be aware, to experience, to know. If minds can emerge from sufficiently complex arrangements of matter, then an infinite universe would contain infinite consciousnesses, each with its own unique perspective on existence. These questions touch on some of the deepest mysteries of human experience: the nature of consciousness, the relationship between mind and matter, the possibility of life after death. In an infinite universe, these aren't just philosophical abstractions. They're questions that emerge naturally from taking the possibility of cosmic infinity seriously. The search for extraterrestrial intelligence has taken on new urgency in light of these cosmic possibilities. If the universe is infinite, then life must exist elsewhere, not just in our galaxy, but in countless other regions of space, perhaps in forms so alien that we wouldn't recognize them as life at all. The Drake equation, which attempts to estimate the number of communicating civilizations in our galaxy, becomes almost trivial in an infinite universe because the answer would be infinite, regardless of how rare intelligent life might be. Somewhere in the vast expanse there would be civilizations so advanced that their technology would seem like magic to us. But the Fermi paradox, which asks why we haven't encountered any signs of extraterrestrial intelligence despite the vast number of potentially habitable worlds, becomes even more puzzling in an infinite universe. If life is common, then where is everyone? The silence of the cosmos becomes more mysterious, not less. Recent discoveries of exoplanets have shown that planetary systems are incredibly common in our galaxy, with billions of potentially habitable worlds orbiting sun-like stars. If this abundance extends throughout infinite space, then the cosmos would be teeming with life in forms we can barely imagine. The possibility of infinite life also raises questions about the nature of evolution and complexity. If every possible arrangement of matter exists somewhere, then every possible evolutionary pathway would be explored somewhere in the vast expanse. There would be worlds where life took radically different paths, leading to forms of consciousness and intelligence that we can't even conceive. Some of these alien minds might have already solved the riddle of cosmic infinity. They might have developed instruments capable of mapping the global topology of space, or mathematical frameworks that definitively prove whether the universe is finite or infinite. In an infinite cosmos, every possible discovery has already been made by someone, somewhere. But this raises a beautiful paradox. If infinite minds have already discovered everything there is to know, why do we still find ourselves wondering about these questions? Perhaps it's because the joy of discovery isn't diminished by the fact that others have made the same discoveries. Each mind that encounters a new truth experiences the wonder of understanding for the first time. The possibility of time travel in an infinite universe adds another layer of complexity to these questions. If space-time has certain topological properties, then it might be possible to travel not just through space, but through time itself, connecting different regions of the infinite expanse in ways that violate our everyday understanding of causality. Closed, time-like curves, solutions to Einstein's equations that allow for backwards time travel, might exist in certain regions of infinite space, creating loops where cause and effect become entangled in ways that challenge our understanding of free will and determinism. Wormholes, hypothetical tunnels through space-time that could connect distant regions of the universe, might provide shortcuts through infinite space, allowing for instantaneous travel between regions that would otherwise be separated by vast distances. These exotic possibilities remind us that even our most basic assumptions about space and time might be too limited to capture the true nature of an infinite cosmos. The universe seems to delight in revealing possibilities that are stranger and more wonderful than anything we could have imagined. The role of consciousness in shaping reality becomes even more intriguing in an infinite universe. Some interpretations of quantum mechanics suggest that consciousness plays a fundamental role in determining the nature of physical reality. If this is true, then an infinite universe filled with infinite minds might be constantly creating new realities through the act of observation. The anthropic principle, which suggests that the universe appears fine-tuned for life because we exist to observe it, takes on new meaning in an infinite cosmos. If every possible universe exists somewhere, then we naturally find ourselves in one that's capable of supporting conscious observers. But this raises questions about the nature of probability and prediction in an infinite multiverse. If every possible observation occurs infinitely many times, how do we make sense of the apparent fine-tuning of physical constants that allow for the existence of stars, planets, and life? The landscape of string theory suggests that there might be an enormous number of possible universes, each with different values for the fundamental constants of nature. In an infinite multiverse, all of these possibilities would be realized somewhere, creating a vast cosmic laboratory where every possible experiment is being conducted. The implications for the search for a theory of everything become both more exciting and more challenging in an infinite universe. Such a theory would need to explain not just the laws of physics in our observable region, but the possible variation of those laws across infinite space. The role of symmetry in physics might take on new significance in an infinite cosmos. Symmetries are often broken in our local region of space, but they might be preserved on the larger scales, creating a kind of cosmic democracy where every possible symmetry and symmetry-breaking pattern exists somewhere. The nature of mathematical truth itself becomes more mysterious in an infinite universe. If mathematics is discovered rather than invented, then mathematical truths would exist independently of any particular minds that discover them. But if mathematics is a creation of conscious minds, then an infinite universe filled with infinite mathematicians might be constantly creating new mathematical realities. The relationship between physics and mathematics, which has always been one of the deepest mysteries in science, becomes even more profound in an infinite cosmos. Are mathematical structures the fundamental reality of which physical universes are merely shadows? Or are physical processes the primary reality that gives rise to mathematical descriptions? These questions push the boundaries of human understanding in ways that are both exhilarating and humbling. They remind us that even our most sophisticated theories and observations might be just the beginning of a much larger journey of discovery. The development of new mathematical frameworks for dealing with infinity has become crucial for making progress on these questions. Set theory, which deals with infinite collections of objects, has revealed that there are different sizes of infinity. Some infinities are larger than others in ways that challenge our intuitive understanding. The continuum hypothesis, which asks whether there are any infinite sets larger than the integers but smaller than the real numbers, has been shown to be independent of the standard axioms of mathematics. This suggests that questions about infinity might not have unique answers but depend on the mathematical framework we choose to work within. Category theory, which studies the relationships between different mathematical structures, has provided new ways of thinking about infinity that might be more appropriate for describing the nature of space and time in an infinite universe. The development of non-standard analysis has shown that infinitely small and infinitely large numbers can be treated as rigorously as finite numbers, opening new avenues for exploring the mathematics of cosmic infinity. These mathematical developments are not just abstract exercises. They're providing new tools for understanding the physical nature of infinite space and the possibilities it contains. The philosophy of science itself has been transformed by these questions about cosmic infinity. The traditional view that scientific theories should make testable predictions becomes more complicated when dealing with infinite systems, where every possible outcome occurs infinitely many times. The problem of induction, which asks how we can justify making general statements based on finite observations, becomes even more acute in an infinite universe, where any finite sample might be completely unrepresentative of the whole. The relationship between theory and observation, which has always been at the heart of the scientific method, takes on new complexity when dealing with phenomena that might be forever beyond our observational reach. These challenges don't invalidate the scientific approach, but they do require us to develop new ways of thinking about evidence, prediction, and the nature of scientific knowledge itself. The ethical implications of cosmic infinity continue to challenge our understanding of moral responsibility and the meaning of individual actions. If every possible choice is made by someone, somewhere, in infinite space, what gives any particular choice its moral significance? Some philosophers have argued that infinite possibilities make individual actions meaningless because every possible outcome occurs regardless of what any particular person chooses. But others contend that this makes each choice more significant because it contributes to the infinite moral landscape of existence. The question of whether suffering is justified by the existence of infinite joy, or whether finite suffering can be outweighed by infinite happiness, has become a central concern in the philosophy of infinite ethics. These questions don't have easy answers, but they remind us that the search for cosmic infinity is not just an intellectual exercise. It's a journey that touches the deepest questions about what it means to be human in a possibly infinite cosmos. The role of hope and wonder in sustaining this cosmic quest cannot be overstated. The search for answers to these ultimate questions requires a kind of faith that the universe is comprehensible, that consciousness can reach toward truth even across infinite distances and infinite time. This faith is not blind, but based on the remarkable success of human reason in uncovering the secrets of the cosmos. From the orbits of planets to the structure of atoms, we have shown that the universe speaks a language that minds can learn to understand, whether space ends or goes on forever, whether we live in one universe or infinitely many. This capacity for wonder, this ability to ask questions that push the boundaries of understanding, is itself a kind of miracle that deserves our deepest gratitude and respect. The search for cosmic infinity has revealed that we are not separate from the universe we study, but part of it, participants in its ongoing journey of self-discovery. Through consciousness, the universe has created beings capable of contemplating their own cosmic context. And in that contemplation, something infinite touches something finite in the most beautiful possible way. And so, as we drift toward the end of our cosmic journey tonight, let us hold this thought gently in our minds. Whether space is finite or infinite, it has given rise to consciousness. And consciousness has given rise to the eternal quest to understand. That quest, that capacity for wonder, is itself a kind of infinity that makes every moment precious, every question valuable, every dream of understanding worth pursuing. The stars above us tonight are not just distant suns but beacons of possibility, reminders that the universe is vast enough to contain every story that could be told, rich enough to support every form of beauty that could exist, and mysterious enough to keep us wondering for as long as consciousness endures. In that wondering, in that eternal reaching toward understanding, we touch something infinite within ourselves. And perhaps that is answer enough to the question of whether space goes on forever. Because in the end, the most profound infinity might not be the one we seek in the cosmos, but the one we discover in the boundless capacity of consciousness to wonder, to question, and to find meaning in the vast, mysterious universe that we call home. Sweet dreams, fellow traveller, and may your dreams be filled with infinite possibilities. As we drift toward the gentle close of our cosmic journey tonight, I find myself thinking about something rather wonderful, the way this ancient question continues to evolve, like a river that has been flowing for thousands of years, gathering new tributaries of knowledge and wonder with each passing generation. The search for cosmic infinity has taught us that the most profound questions often don't have simple answers, but that's precisely what makes them so beautiful. Whether space ends or goes on forever, the quest to understand has already given us something invaluable, a deeper appreciation for the mystery and majesty of existence itself. We've seen how the geometry of the universe hints at infinite possibilities, how the cosmic microwave background whispers secrets about the nature of space, and how dark energy continues to reshape our understanding of what it means for something to expand forever. We've contemplated the mind-bending implications of eternal inflation, where our entire observable universe might be just one bubble in an infinite sea of cosmic possibility. But perhaps the most remarkable discovery is this. In our quest to understand whether space is infinite, we've discovered something infinite within ourselves, the capacity to wonder, to question, to reach beyond the boundaries of our everyday experience and contemplate the ultimate nature of reality. This boundless curiosity, this eternal reaching toward understanding, might be the closest thing to true infinity that we can ever really know. Whether the universe contains infinite copies of ourselves, living infinite variations of our story, or whether we exist in a finite cosmos that curves back on itself in elegant loops, we find ourselves here, now, in this moment of cosmic history, able to participate in humanity's greatest adventure. We are star stuff that has learned to wonder about stars, temporary patterns of atoms that can contemplate eternity. The question of whether space ends or goes on forever may remain forever beyond our definitive grasp, but the search itself has transformed us. It has connected us to the cosmos that gave us birth, to the long chain of curious minds that have pondered these same mysteries throughout history, and to the infinite potential that lies within conscious beings capable of asking such profound questions. So as you drift off to sleep tonight, Wherever you are in this vast and mysterious universe, carry with you this thought. Whether space is finite or infinite, bounded or boundless, it has given rise to consciousness, and consciousness has given rise to wonder. And in that wonder, in that eternal quest to understand, we touch something truly infinite. The stars above us will continue to shine long after we're gone, illuminating the path for future generations of cosmic explorers. But right now, in this quiet moment, you are part of something magnificent. You are the universe contemplating itself, asking questions about its own nature, finding beauty in the very act of wondering. And perhaps that's the most beautiful answer of all. Not whether space goes on forever, but that it has created beings capable of asking the question in the first place. In a cosmos that might contain every possible story, this particular version of you is here, now, participating in the eternal human quest to understand our place in the infinite tapestry of existence. Sweet dreams, fellow traveller. May your rest be peaceful, your dreams filled with cosmic wonder, and may you wake tomorrow with the same sense of awe that has driven humanity to reach for the stars and ask the biggest questions of all. Until we meet again in this gentle corner of curiosity, sleep well and remember, whether space ends or goes on forever, the capacity to wonder about it is itself a kind of infinity that makes every moment precious, every question valuable, and every dream of understanding worth pursuing. Thank you for joining me on this cosmic journey. Good night.